Right, hello. So what I'm going to do today is look at common problems that you will find in your programming exam. So the first one is adding semicolons. Oi, 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 shh, thank you. Adding semicolons in an if and a while loop. Right, so if you look at this example here, you can see that looks all right, it runs. Okay, so if I just run that, you'll see that it will run without any errors. It says x is 5, and we know that x isn't 5, x is actually 4. Now the reason for that is because we've got that semicolon there. Now if you try and put an else there, you'll actually come up with an error. So now it's not liking it at all. All right, but if you didn't have that, it would compile. All right, it would run, but the if wouldn't work at all properly. Okay, so we need to get rid of that. Now when we run it, we should get nothing in the window. So let's have a look. Okay, so that is the first one, and you see that quite a lot, and it is difficult to spot. All right, so that's right. Okay, so be aware. So if in doubt, just always use the code snippet like that. Okay, and notice you didn't put a semicolon in there. The other thing is, if you do a while loop, again, if you put a semicolon there, it's not going to like it. But if you do a do while, on the other hand, notice that does have a semicolon there. All right, so just use the snippet and don't get it wrong. Right, okay, so the next one then is reading the ASCII code rather than the digit from a string. Right, okay, so often we will have like this, so we'll say string oh my god, that didn't work out, did it? Let's try again. String x equals 1 2 3 4. Okay, now so if I said int num equals convert dot to int 32, yeah, we'll have that, x, and then we'll do it on the first character, so that's 0. Okay, now, and then if we write out there, what's wrong with that? Oh, because I've already got x, idiot. Let's go to that, sorry. Right, there we go. So now, if I just did console right line num, let's see what we get. So when we run that, we get 49, which is the ASCII code for 1. Okay, so 49 is the ASCII code for 1. Remember, x0 is the first character, x1 would be 2, and so forth. So if we wanted the actual number 1, then we have to convert that to a string. Okay, so don't forget. There we go. So now when we run it, we should get it. Now you might find you want the ASCII code, but and that's a way to get the ASCII code, but often you don't. So there we get the 1. All right. So just bear that in mind. Without the toString, it won't get it. Now, if you could just use substring, which returns it as a string anyway. It's because that returns it as a char, converting a char into an integer gives you the value rather than the actual character it represents. All right. Okay, so that's number 2. Using functions incorrectly. Well, okay, that's a bit vague, but I'll tell you what I mean by that. Now, so let's say that this one now contains A, B, C, D. Okay, and let's get rid of that. and I'm just going to right line x. Now what often people do, if I want to convert that to upper, I go x dot to upper. Okay, and semicolon on there. And that looks right. But if I run that, it's still lowercase, right? Because upper, it returns a copy of the string. Okay, so it doesn't change it. So you have to say x equals x dot to upper there. All right. Now we've got it. All right. So that's often the thing people don't do. Now, be aware if you're using other functions. Like, do you remember we did with lists here? We did list.reverse. There we go here. Now, if you look at that, it says reverses the order of elements of the list. I don't need to say that one found val list equals found val list.reverse. So just be a bit careful about that. So when it's like a this function here, it does actually reverse the list. We don't have to make it something equal to it. But with strings, you do have to make them equal to it if you are changing something. Okay. Right. So that is another one. Screen capturing code. Right, okay. So what a lot of people will do is go, right, okay, there's my code here. Windows Shift S. Get the screen capture. Go and chuck that into my EAD. There. Okay, it looks nice. I mean, it undoubtedly does look nice there. But it's hard for the examiner to mark it. If you've got very long code, very wide code, then you have to make it very small. It's going to be difficult to read. Even though it doesn't look as good, just copy and paste it. All right, so just Control C and paste it. You can keep the colours if they're. Now that looked pretty bad, didn't it? You know, you could, in theory, I suppose, if you did it from there, that would have made a better job of it. All right, let's see what that looks like. Yeah, that looks better. All right, admittedly, you lose some stuff over there, but you know, tough luck. All right, so let's get rid of that. All right, so just copy and paste code. Don't go and screen capture code. Obviously, you need to screen capture the console application, console window. Right, okay. Next one then is spending too long on questions. Now, in the paper, it will say, let's have a look, exam papers. Paper 1. Okay. It will give you 20 minutes on this section. So section B is write a program. This is the one where people are very guilty of spending too much time. So do keep an eye on the time and don't spend too long on these questions. You can always come back to them. Now the last bit is code not pasted in the EAD. Now when the final time goes, you will not be able to do any more typing. Okay, so make sure, even if it's incomplete, that you get code in the EAD. If it's not in the EAD when the time's up, you're not allowed to add any more code into it. You can't just say, well, it's my programming time. No, it's not. You've got to get it all into your Word document by the end of the exam. So if you just finish a bit of code and the exam finishes, and if it's not in EAD, then you're stuffed. Right? You're not going to get any credit for it. So make sure all code, even if it's not working, is in EAD. So make sure you give yourself time at the end. All right? Okay, that's it, basically. There we go.